All right, distribute. So you should have distributed like this, right? And then you got 21 x times x is x squared. Did you get that for your first term? Okay. Then 7x times minus 2 or negative 2 is going to give you negative 14x. Is that one good? Okay. Next one, when we multiply these two fractions together, I like to start by multiplying across like this. And so 3 times 4 is 12. X to the 3, y. And then 2x. And then when we divide, we'll divide the number, so that's going to give me a 6. But we'll subtract the exponents. So remember, x is x to the 1. So I get 6x squared, y. That's all in the numerator. So since I don't have a denominator, I no longer have a fraction. So it's just that. Questions on 1 and 2? Okay, I'm going to pause for a second because I see some of you are catching up, and then we'll do that factoring problem. And then actually, I feel like I'd like to do another factoring problem, but I don't really have space for it. We'll figure it out. All right, so this one, we're just looking for the numbers that multiply to 6 and add to 5. What were the numbers that multiply to 6 and add to 5? 3 and 2, good. So then your factors are x plus 3 times x plus 2. That was an easy kind of factoring because we just had 1x squared. But let's review a problem that's a little bit harder because you are going to have to do some of these today. So 2x squared plus 5x minus 18. So hopefully you can fit this in the corner of your work here. This one, because you have a number in front of the x squared that doesn't factor out, we have to do this longer method. You start by multiplying the first and the last number. And so I'm looking for two numbers that multiply to negative 36. And they still have to add to 5. So they're adding to 5 and they're multiplying to negative 36. So I can start making a list of numbers. Negative 1, negative 2, negative 3, negative 4. And then I found the numbers that add to 5. So I have 2x squared minus 4x plus 9x, and then minus 18. Okay, I'm going to take my greatest common factor out of the first two, which is 2x. That leaves me x minus 2. And then the greatest common factor of the second two is 9, and that's x minus 2. These match, so x minus 2 times 2x plus 9. I want you to take a minute and make sure you have this down as an example, because when we get to some of these problems that need some harder factoring, you're going to want an example to look back on. So, when we multiply rational expressions, I could distribute this to everything, but the thing is, I'm really hoping something's going to cancel out, and for something to cancel out, it has to be multiplied. It can't be added or subtracted. So what I'm going to do is I'm going to factor wherever I can. This problem has a common factor of 6, so I can take out my common factor of 6. When I divide 6x by 6, I get 1x, and when I divide minus 6 by 6, I get minus 1. You can do the same thing for the 9x minus 9. You can factor out the 9, and we have x minus 1. All right, so now the top has 3 different factors. The bottom has 3 different factors. So on the top, I have 6 times 2, that's 12. I have x squared, and I have x minus 1. On the bottom, I have 9x, and I have x minus 1. Okay, 12 times x squared times x minus 1. 9 times x minus 1. Because these x minus 1s are being multiplied by everything else, and because division undoes multiplication, you can cancel these. And now this problem is really just a lot like this one that we just did in the warm-up. 12 over 9, some of you can simplify that because you know that those numbers both divide by 3. So 12 divided by 3 is 4, and 9 divided by 3 is 3. But if you want to do that on your calculator, and if you don't have a calculator, feel free to grab one. To do that on your calculator, you can also do 12 divided by 9, and you get a decimal, but then you do math, fraction, and you also get 4/3. Okay, so 12 over 9 becomes 4 over 3. And then here I'm going to subtract my exponents and get x to the 1. And that's my final answer. What questions do you have on that? Okay, let's do one more together and then you guys will work on 3. So in problem 2, I can actually already see that the 7 n's are going to cancel out, and I can actually cancel them at this point if I want to. You could wait and cancel them later, that'd be fine, but you can cancel them at that point. When two fractions are being multiplied, it really is like you have one big happy fraction there. So you can make that one fraction. And then here I'm going to factor out what's the greatest common factor of 9, n, and 24. I heard a vote for 3. That's right. So I'm going to factor out the 3. 9 divided by 3 is 3. And 24 divided by 3 is 8. All right, in the denominator, I'm trying to think, what's the greatest common factor of 24 and 64? That might take a minute. Like, I know 2 divides them both, but there's probably a bigger number. Dylan, what do you think?
8.
Anybody else think that they both divide by 8? Yeah. And I'm looking to see, is there a bigger one? So 24 divides by 12, but 64 doesn't divide by 12. So I think Dylan found the biggest one. So I'm going to take out 8. This has n to the 3, and this has n to the 2. So I can also factor out n squared. Okay, 24 divided by 8 is 3. And n to the 3 divided by n squared is n to the 1. 64n squared divided by 8n squared is 8. And really, like in most of these problems, something is going to cancel. Sometimes not everything cancels, but usually something's going to cancel. So the fact that we have 3n minus 8 and 3n minus 8 means we're probably on the right track here. So these will cancel like this, and then we get 3 over 8n squared. Okay. Questions on 2? All right, I want you guys to try 3. Anything that can be factored, I want you to factor. Okay, 10x minus 40. I know a lot of you factored out a 5 to start, but then you realized you could actually factor out what bigger number? 10, good. So you're going to factor out the 10, and 10 times x is the 10x. 10 times minus 4 is the minus 40. Then down here, 5x plus 15, what can we factor out? 5, good. So here's the 5. 5 times x makes the 5x, and 5 times 3 makes the 15. Now this one here, it's already its own factor. You can just put parentheses on it, like that. It's fine. It's already a factor. And then here, we had to find two numbers that multiply to 8 and add to negative 6. And what were those numbers? -2 and -4. Good. So x minus 2, x minus 4. Now, Ian points out now you can just like cross them out. You don't have to rewrite it, but I just like to keep things organized so you can see like where everything's going. So if you're understanding this and that makes sense to you, feel free to do that. I'm just going to write mine out again. So 10 times x minus 4 times x plus 3. I'm going to move this 5 out front so I don't lose track of it. X minus 2, x minus 4, and x plus 3. Okay, so everything on the top comes to the top, everything on the bottom comes to the bottom. And so we see the x minus 4's cancel and the x plus 3's cancel. 10 divided by 5 gives me what? 2. So I have a 2 on the top, and I have an x minus 2 on the bottom. Who can tell me, I want you to think about this for a minute, and raise your hand if you have just even an idea. Who can tell me why these 2's don't cancel? All right, raise your hand if you think you have an idea, if you notice anything. Why don't the 2's cancel? Okay, it's really important to know that these 2's don't cancel, because if you got to this point, you got the right answer, and then you just went on and you canceled the 2's, you would totally get the wrong answer and you would lose a lot of points on a quiz. So right here, between the 2 and the x is a minus, right? Subtraction is not the inverse of division, so we can't undo this subtraction with division. It will not cancel. It's only here that we can cancel because we know that between these parentheses, all these things are being multiplied. Multiplication and division are inverses, so they can undo each other. So here, you are done. All right, this review problem right here, this is kind of like the second problem on your warm-up, so give this one a try real quick. Sometimes we like combine the two ideas, so it's good to review this. And then I think on the back we're going to be working on division. All right, I'm hearing some good collaboration. 4 times the 9, you should have a 36 there. And then x to the 3, y to the 5. And then in the denominator, what was 9 times 16? What is it? 144? Is that right? Okay. I couldn't do that in my head. I don't know why. And then x squared y. Remember that y is a y to the 1, and putting the exponent there will help us get that right. All right. I think 144 is divisible by 36. Did anybody simplify 36 over 144 yet? What is it? 1 over 4. Beautiful. All right. And then I have x to the 3 over x to the 2, so I can subtract my exponents and get x to the 1. And y to the 5 over y to the 1, subtract my exponents and get y to the 4. Any questions on that one? Did I need to put the 1 in front of the x? No, I didn't have to, but it's not wrong. It's either way, okay? All right. Anybody still want a second? Yeah. And then we'll turn and we'll see what division we have on the back. All right. So when we divide, let's remember how we would divide fractions like in elementary school. When we divided fractions, we took that 3/7, changed the divide to multiply, and then the second fraction became its reciprocal. So dividing by a fraction is the same as multiplying by its reciprocal. And then we would get 36 over 35. Okay? So you just change your divide to multiply, and then your second fraction, use the reciprocal. Okay. So for this one, I've got 4 x to the 4 over 3. Change my divide to multiply, and then find the reciprocal of the second fraction. You really have a choice. You could multiply and then simplify, or you could simplify first. It's up to you. But do you see what I did? I just flipped that second fraction. I'll multiply, so I get 24 x to the 4 over 3x to the 3. And then I'm going to divide the 24 and the 3 and subtract my exponents. And it's just that, 8x. So the thing that was new here is that in order to divide, we change to multiply, and we do the reciprocal of the second fraction. And then it's still like a multiply problem. In problem 2, we have an x squared minus 4. Do you guys remember factoring something like x squared minus 4? It was called the difference of what? The difference of, what are these? Squares, thank you. All right, difference of squares. So when we had the difference of squares, it was that plus minus pattern. So we get the x squared from x times x. And then we got the minus 4 with a 2 times a negative 2. And the reason why that works out is because the middle terms cancel out. So we had a 2x and a negative 2x in the middle. They canceled out, and it gave us just x squared minus 4. Okay, so I have, on top I have x plus 2, x minus 2, over 20 y to the 4. Change my divide to multiply. And then I'm going to flip my second fraction, so I have 16y squared. And for this one, I need to factor out a common factor. 3x plus 6, what can I factor out? What can I divide 3x and 6 by? 3, good. So this one becomes 3 times x plus 2, and that goes here. Are these x's or y's? It's funny, it has x's and y's in it, but that's not a big deal. So your x plus 2 and your x plus 2 will cancel. I'm going to move my 16y squared to the front times x minus 2. And then through 20 times 3 is 60. Y to the 4. Okay, 16 over 60, they both divide by 16. So I think this is going to become 1 over 5. When I subtract my exponents for the y's, I get y squared. Do they go on the top or on the bottom? They go on the bottom, right, because there's more y's on the bottom. So my y squared's on the bottom. And then my x minus 2 is on the top. All right, I want you guys to try problem 4. There's a couple things tricky about problem 3, so we'll go back to that one. But I want you guys to try problem 4 right now. So remember, you're going to factor everything you can factor. You're going to do reciprocal of the second fraction and change divide to multiply. So down here, I saw some of you factor out a 3. That was beautiful. And then up here, there was some confusion because there's no number that they have in common, but you could factor out what variable? The x, yeah. So this one becomes x times x minus 2. And then here, is this the same thing that we factored in the beginning? No, I felt like we had factored that, but no, it's not. Okay, so multiplies to 8 and adds to negative 6. What were those numbers? Yeah, negative 4 and negative 2. Okay, good morning. So now I'm going to take the 5x and the 3 times the x minus 4. And then this is going to be times, oh, actually I have to flip this, I forgot. So this comes to the top, and this comes to the bottom. So this is going to be x minus 4, x minus 2 on the top, and then this is on the bottom.
That's your break.
Good, thank you. All right, so now we're in good shape because our x minus 4s are going to cancel, our x minus 2s are going to cancel, and we can cancel these x's here because this is 5 times x and this is 3 times x. And so because that's multiplication, these can cancel, and we can get just 5/3 as our answer. All right.
Oh, wait.
I feel like some of you are still catching up on that one, so then we're going to go back to 3. But if you are ahead and you're like, you know, I'm just tired of sitting here, please try that challenge problem because that's not one that we're going to do together. That is a challenge problem. Okay, may I move on? Can I go back to 3 now? All right, make sure you have lots of examples so that you can be a helpful group member when we go to our boards. All right, one thing that's tricky about this is that when you do the reciprocal of the second part, there's no fraction. So you can make it a fraction by putting it over 1, and then you'll just do the reciprocal. Here, I need to factor 2x squared minus 5x plus 3. And so I need to multiply these two together and find two numbers that multiply to 6, but add to -5. So I'm actually going to have to do a little bit of work factoring before I can do anything else. All right, so multiply to 6 and add to -5. I could do -2 and -3. And so what I'm going to do is I'm going to rewrite this, 2x squared, and instead of the -5x, I have minus 2x minus 3x, and then plus 3. And I'm just dealing with that right now because it's going to take me a minute to factor this. Okay, first two terms have a common factor of 2x. So when I take that out, I have x minus 1. The second two terms, a lot of you can see that you can divide them by 3, but if the first term of those two is negative, you want to factor out a -3. So factor out a -3, and then this becomes x minus 1, which matches. So by factoring out that -3, we get our parentheses to match. And then this is 2x minus 3 times x minus 1. I'm going to put that over the 2x squared. I'm going to change divide to multiply. And when I flip this fraction, I'm also going to factor out what's the common factor between 2x squared and minus 3x. It's not a number. What is it?
What is it?
What's the common factor between 2x squared and minus 3x? What is it?
X.
X, right. We're going to factor out x. So we'll take the x on the outside. X times 2x gets me that 2x squared. And then x times minus 3 gives me the minus 3x. Okay, so this one and this one will cancel. On the top, I still have x minus 1. That didn't go away. X minus 1 times 1 is just x minus 1. On the bottom, I do want to multiply. 2x squared times x to the 1 is going to give me 2x to the 3. Okay, and then if you did try that challenge problem, I believe that should be on the key, the PDF key, so you can check your work in Schoology.